Let's read this together. It says, a boat which moves at 18 miles an hour in still water travels 14 miles downstream in the same amount of time it takes to travel 10 miles back upstream. Find the speed of the current. Okay, so we want to find the speed of the current. So why don't we start right here and say that x equal the speed of the current. After all, that's what's unknown. I'm going to draw a picture so I can get a better feel for what's happening here. Suppose here's this river, and we have a current maybe going this way. How fast is it? We don't know, x. Right, so the current's going this way here at x miles per hour, and we know that in a boat we go 18 miles per hour in still water. All right, that's with no current at all. Boat goes 18 miles an hour. Now it goes 14 miles downstream. So suppose that we started right here, and we go, and we go 14 miles here, right? 14 miles down here. Then we turn around and we come back, but because we're going against the current in the same amount of time, we only go 10 miles. Now there is something we need to know here. We need to know the distance is equal to rate times time. And this is probably familiar to you. You know, if you're going 60 miles an hour for 2 hours, how far have you gone? The distance is 120 miles, right? So the distance you travel is equal to your rate times your time, the speed times the time. Now what I see here is that we have two different distances, right? We're going downstream and then we're coming back upstream. So let's look at downstream. I'll do d sub d for downstream. The distance traveled downstream is the rate times the time. Now that distance is 14 miles. And what is the rate? Well, the rate is going to be, well, we're traveling with the current, right? So how fast would you be going? So think about this now. Here you are traveling down here. You're going at some speed, but the current is pushing you also. So if it was still water, you'd be going 18 miles an hour, but you're getting pushed by the current. So I think our rate here is, if I can write it here, 18 plus x. And you heard him, apparently my cat agrees. And here is a picture of my cat. His name is Bones. All right, but let's go on here. So what have we got? D, the distance downstream is equal to rate times time. And the distance is 14. Here's our rate, right? The amount we can, the speed we travel in still water plus the current's pushing us. And then this has to be multiplied by time, right? So that all gets multiplied by time. So this is the distance downstream, right? 14 miles in this rate and this amount of time. Now let's look at the distance upstream. So the distance, how about u for upstream? Well, that's rate times time also. Now the distance coming back, right, we only get 10 miles here. So this is going to be a 10. This is equal to our rate. Now what's the rate? In still water, we can go, I'm over here now, in still water we can go 18 miles an hour. But we're getting pushed back, right? We're getting pushed back by the current. So just for example, suppose in still water we can go 18 miles an hour, but the current is 1 mile an hour. So we're getting pushed back 1 mile an hour, so we're really going only what? 17 miles an hour? So in general, it's going to be, can you see it? It's going to be 18 in still water minus the speed of the current, and then times the amount of time that we travel. Now I'm going to solve both of these equations for t. So I'm going to divide by this, divide by this. So over here, I'm going to get t equals 14 over 18 plus x, and over here I get t equals 10 over 18 minus x. And we know from the problem, it says we travel the 14 miles down and the 10 miles back up in the same amount of time. So you know now that these two times are equal. This time and this time, these are equal. So if I set these equal to each other now, let's do that. I'll have 14 over 18 plus x. That's equal to 10 over 18 minus x. And there's a rational equation that we can solve. And I think we're pretty good at this. Let's get the LCD. We have the 18 plus x and the 18 minus x. And x cannot equal, what, negative 18 or 18. Because what is x anyway? X is the speed of the current, and we're told that there is some current. Okay, so let's multiply. We know what to do here, right? You write the LCD in front of both original terms. So I'm going to do that right over here. I'm going to get us a little bit more room, so I'm going to write the 18 plus x, 18 minus x times 14 over 18 plus x, right? So I've taken the LCD and I write it here, and I'm going to write it here, right? You write it, the LCD in front of every original term. So equals 18 plus x, 18 minus x, dot 10 over 18 minus x. And now we get some cancellations, right? The 18 plus x goes out, and we are left with 18 minus x times 14. So let's write that. We'll have, I'll do it in the same color here. We're going to have 14 times 18 minus x equals, and on the right side, the 18 minus x's cancel, and we are left with 10 times 18 plus x. So let's do that one. 10, 18 plus x. So let's multiply through. On my calculator, I found 14 times 18 is 252 minus 14x equals, this one I can do, 180 plus 10x. Let's see, why don't we add 14x to each side? So we'll get 252 is equal to 180. Now 10x and 14x is 24x. And then I'm going to subtract the 180. So 252 minus 180 is 72 equals 24x. And then, let's go up here where we have some room. 72, oh, let's write it so we can see it. 72 divided by 24 is x, and that turns out to be 3. Now the question here is, what is the speed of the current? The answer is not x equals 3. X was the speed of the current, so the speed of the current is just 3 miles per hour.